Find the greatest common factor of the terms in each expression. So you're just looking at these expressions here, and all you're going to do is find the greatest factor. So you're factoring the polynomial, because these are called polynomials. So if you're looking at the terms, how many terms do you have in this first statement? 2. So you're going to factor 8c and 10. So you're basically ignoring that plus sign, okay? So you're just going to go ahead and factor 8c and 10. Well, how do we factor 8? We make a what? Not a box. How did we factor numbers last week? How did we find the greatest common factor of numbers last week? The factor tree, yeah. Tree. So what two factors or what two numbers can I multiply together to get 8?
2 and 4.
Okay. And because 2 is prime, what makes a number prime?
You can't only multiply it by 1 or something.
Yeah. It only has two factors. It only has two numbers that can be multiplied by the number 1 and the actual number itself. Okay, can I factor 4? Can I think of more than two factors for 4? 2 and 2.
Yeah.
Okay. And then I'm going to come to 10. I'm going to factor 10 as well. What two numbers can I multiply together for 10?
2 and 5.
2 and 5. Now, what do I do with these prime numbers after I factor them? Yeah, so I'm going to list 8 and 10. So what are my numbers for 8?
All 2s.
All 2s. I have 3 of them, right? And then for 10?
2, 1, 2, and 1, 5.
And then what?
Circle the ones that are the same.
The ones that they have in common, right? So what do they have in common?
2 and 2.
So the greatest common factor will be
2.
2. Now we have to look at the variable. Do they both have the variable c?
No.
No. So the greatest common factor for those two terms is just 2. So basically, we're doing the exact same thing from last week, but this time I put them up in an expression. Now, what makes this an expression?
There's no equal sign.
That's right, no equal sign. Okay, so this time I need to find the greatest common factor for how many terms? 3. So we're going to follow the same steps. Let's see, Logan, what are my factors of 32? What two numbers can I multiply together to get 32?
32?
Yeah. Does it end in an even number?
Yeah.
So we know all even numbers are divisible by 2. So take 32 divided by 2, and what do you get?
32 divided by 2?
Mm-hmm.
16.
So we know that 2 times 16 will get me to 32. What else could you multiply together to get 32?
4 and 8.
4 and 8. Did anybody use 4 and 8? That's completely fine. Remember, you don't have to use the same two starting factors. The main thing is at the end that we end up with the same prime numbers. So we know that 2 is prime. All right, Logan, what are two numbers or two factors that I can multiply together to get 16?
4.
And?
4.
4, yeah. All right. And then 4 can be factored. What two numbers can I factor or multiply?
2.
And then 2 and 2. There's lots of 2's there, aren't there? Okay? Maddie, do 28 for me. Now, although that's a negative 28, we're going to ignore that negative for right now, okay? That negative is not going to be important to us. We're just focusing on the coefficient and the variables. So 28, go ahead and factor for me.
Would it be 2 times something?
Yep. What are you doing? Are you going through 2 times this, 2 times that? What's an easier way to do that?
Yeah.
Take 28 divided by 2, and that'll give you the number you can multiply it by. Okay. And what did you get? 28 divided by 2. So put your big number in first.
Oh, that's what I didn't do.
I know I did.
14, right? So we know that 2 is prime. What are two numbers I can multiply together to get 14?
7, 2 and 7.
Okay. What about for 7?
9.
That's prime, right? Okay. 24, Danny.
Add 2 and 12.
For 12.
Add 2 and 6.
And then for 6.
2 and 3.
All right. So now I have 3 lists that I need to write out here. Ooh, I'm going to run out of room if I'm not careful. So I have 32. How many 2s do I have for 32?
You
You
have
have
5, 2.
2, 4, 5.
2, 3, 4, 5. Okay. For 28, I have 2.
1, 2, and 1 sub.
And then for 24,
3 2s and 1 3.
okay. Ooh, that was, there we go. So from here, I circle what they have in common. So what do they all have in common?
2s.
A 2. Okay. Anything else?
2.
Another group of 2s. So then the greatest common factor will be what?
2 times 2,
Which equals?
4.
Okay. So 4. And then we have to look at our variables. Do they all have an A?
Yes.
Do all 3 terms have an A? Yes. Now, our notes last week said, which one do I use then? Ben?
The one with the lowest number.
The lowest exponent. So which A has the lowest exponent?
A.
Yeah, A. The A by itself is going to have the lowest exponent. Because A by itself is actually A to what power?
1.
Yeah. Okay, do they all 3 have a B?
No.
Since they all don't have them, it cannot be a common factor. So our greatest common factor for these 3 terms is just 4A. Questions?
The back.
The back is hard? Oh, yes. We need to challenge ourselves on this Monday morning, don't we? Let's challenge ourselves. Okay. Why do you say the back's hard? What makes it hard? Is it any different than the front?
No, I don't know why I think it's hard.
You think maybe just some more, maybe because the variables are bigger.
Yeah.
They look a little bit different. Okay, so we're still going to do the same thing. We're going to go ahead and find the prime factors for each number. So 54, what can I multiply together to get 54, Jenna?
9 and 6.
Okay, keep going. Finish this whole one up for me.
9 could be 3 and 3, and circle those, and 6 equal to 3 and 2.
Okay, good. That wasn't too bad, was it? Okay, 45. Maddie. Actually, I lied. Riley. Thank you. What 2 numbers can I multiply together to get 45?
9.
And? Okay, what do I do with my 5?
Circle.
Okay, what do I do with my 9?
3 times.
And then I circle my 3s. Good. And 50. Do you guys know the 0 trick?
Wait, what?
So like you have 50. How many zeros are in 50? 1. So it's basically 5 times 10. So if it would be 500, you could have did 5 times 100. Do you see how I take those 2 zeros and make a number out of it?
I know what you do. You just put 5 and then you put the 100s instead of the hundreds.
So what do I do with 5? Circle it. What do I do with my 10? I can't switch my colors, but that's okay.
2.
2 and 5, and I circle them. Then I come down and I make my list, right? Kind of feel like I'm Santa Claus when I say make your list. Check it twice. Okay, so 54, my prime numbers in order from least to greatest is,
2 times 3 times 3 times 3.
and for 45,
3 times 3 times 5.
and for 50.
2 times 5 times 5.
Now, if I multiply 2 times 5 times 5, what will that equal?
50.
If I take 3 times 3 times 5, what does that equal?
45.
If I take 2 times 3 times 3, what does that equal? 2 times 3 times 3 times 3, what does that equal?
All the same.
Yeah, 54. So basically, these prime numbers, when you multiply them out, should equal out the number that you started with. Okay. What numbers do they all have in common? What numbers do they all share?
2.
Do they all three have a 2?
No.
Okay. Do they all three have a 3?
No.
No.
Do they all three have a 5?
No.
No.
So then what number do they have in common? What? No. Say it again. 1. So the greatest common factor is 1. And then we have to look at our variables. Right? Do they all have an e?
Yeah.
Yep.
Okay. Which one do I pick?
E2.
E to the second, because it's the one with the smallest exponent. Okay. Do they all have an f?
Yep.
Which one do I pick?
F.
F, because it's the smallest. Now, if I wanted to write this answer in simplest form, how could I write it? Do I really need to have that 1 in there?
No.
No, how could I have it?
B squared F.
So either way is an acceptable way to write your final answer here.